Hello student, very good morning to all of you. How are you? I hope you all are fine, healthy and very happy at home. Do you remember what were we discussing yesterday? I think we were discussing about the IR spectroscopy, and in that we are discussing the carbonyl compounds. And as we know that carbonyl compound means there is a carbon oxygen double bond, that type of the functional groups are present and that compound are referred to as a carbonyl group. So let us see what are the point present in that carbonyl group, generally referred as a C double bond O group. Some of the point we have seen over here. Suppose as a point, that is a aldehyde, and that aldehyde we know that the general formula of aldehyde is RCOOH, and I think this aldehyde we talk about that how that aldehyde is mainly the most prominent and the most informative peak is obtained or observed in the IR spectra. One is due to carbonyl group, another one due to the CH stretching. The carbonyl group is nearly around 1720 per centimeter, whereas CH aldehydic stretching frequency is found to be 2750 to 2850 per centimeter. So that are the main, what we can call it as a point. Generally peak observed for aldehyde, right? One is due to the carbonyl group, another one is this one, that we already seen, so no need to discuss. Then second one, generally as a ketone, we know that, right? Second will be the ketone. In that ketone we know that R C double bond O R dash. The ketone also we have discussed regarding that ketone producing only as a one prominent and the most informative peak observed in IR spectra due to the presence of carbonyl group around 1710 to 1715 per centimeter clearly indicate the presence of saturated ketonic group present in the organic compound. That type of the information we are getting by observing or by identifying or by recognizing that peak. The organic chemist generally come to know that there is a carbonyl group is present by observing a spectra carefully, by looking by observing that shape and size. Organic chemists immediately come to know that this peak is due to, or this peak is corresponding to saturated carbonyl compounds. So this type of the prediction they can be predicted. So that is there. And whereas how will you distinguish aldehyde from ketone? And as we know that aldehyde gives a two prominent peak. One is due to the carbonyl group and another due to the aldehydic CH. Whereas in the saturated ketone only one prominent peak is observed, and which is around 1710 to 1715 per centimeter. The peak near or peak between 2750 to 2850 is not, or it is absent in the ketone, and from this the chemist clearly say that this spectra is due to the ketone, and this spectrum is due to the IR compound, and this IR spectrum is due to the aldehyde, and this IR spectrum is due to the ketonic group. By observing the spectrum carefully, they immediately come to know that. Now the third one also we have seen regarding that compound. If you observe, let us see the one of the spectra. Here I am displaying one of the spectra for acetophenone. It is absorption versus, here you can write a frequency, it is in a mu, here is a wavelength which is in a lambda micron, and it is in a per centimeter, and this spectra is for acetophenone. As we know that this is the structure of acetophenone. If you see theoretically how many peaks are observed, look at here, there is a aromatic compound is present. Aromatic compound, the peak will observe around 1500 to 1600 per centimeter. This stretching frequency is due to the carbon-carbon double bond of aromatic compound. Another one, CH bending also there. Another peak, that is a monosubstituted aromatic compound, but the most prominent peak observed in this acetophenone will be due to the carbonyl group, and it is around 1715 per centimeter. Appearance of peak around 1715 per centimeter clearly indicate that there is a presence of carbonyl group. But here that carbonyl group is present in the conjugation. When conjugation is there, the carbonyl stretching frequency will be decreased. The reason behind it, the factor affecting carbonyl group, that time we will study why there is a decrease in a carbonyl group. Either there is a lower in a stretching frequency, or sometime raise as a stretching frequency. There are a number of factors which affecting that stretching frequency that we will study later on. But right now just observe this. I am here, one spectra is displayed here for acetophenone. Let's see here the IR spectra. Generally here you can see here one of the, then one peak around. This type of the peaks are observed, or there may be this in a aromatic region. If you observe this spectra carefully, one strong and recognizable peak, by observing this, the shape and size, the organic chemist immediately come to know that this peak is due to the stretching frequency of carbonyl compound. This one strong and very important prominent peak observed due to the presence of carbonyl group. If you see here, this is a peak around, this peak is observed around 1710 per centimeter, and this peak is due to the carbon-carbon double bond of aromatic compound. The stretching frequency found to be 1500 to 1600 per centimeter. And if you see some peaks in the aromatic region, because from this to this is known as a functional group region up to this, and this is the aromatic region, and the peak observed in aromatic region clearly suggests that there is a aromatic compound is present. If lack of absorption peak in the aromatic region, from that we can immediately conclude that the given organic compound would be non-aromatic in nature. Lack of signal in aromatic region clearly indicate that there is a non-aromatic compound is present. But here you can clearly see these are due to the CH bending vibration, or maybe as we can know the substitution pattern of aromatic compound here mainly as a monosubstituted aromatic compound, and that's why this type of the peaks are observed over there. And now let's see another one is the acids and the esters. So now next point we are going to discuss here, there is this aldehyde and the ketone which we have discussed over here. Now next point we are going to discuss, this will be the C means carboxylic acid, and as we know that the general formula of carboxylic acid are C double bond OH, right? Another one comparatively we are studying, another one is a ester, and as we know that ester has a general formula RC double bond O and O here R. Now if you observe these two structure, their general formula carefully, and the peak generally obtained due to the stretching frequency and the stretching vibration and the bending vibration. And we know that for the condition for IR, and there are two conditions for IR active and IR inactive. Number first are the condition for IR spectrum or condition for IR. Number one, the frequency of the vibration of the bond or frequency used for the excitation is equal to frequency of the IR radiation. They match perfectly, then and then that type of the molecule are known as IR active. That is one of the essential criteria or the condition for IR active. Number two, when there are number of vibrations are taking place, but all the vibrations are not recorded in a IR spectrophotometer, only those vibrations are recorded in the IR spectrophotometer. Those shows change in dipole moment, and that vibration of the vibrations are recorded. Those covalent bond shows change in dipole moment. That type of the vibrations are recorded in the IR spectrophotometer, and that compound are said to be IR active. And if The molecules are the symmetrical one, just like as acetylene, carbon dioxide, nitrogen oxide. Such a type of the compound are linear and their vibrations are symmetrical one. The vibrations are not showing change in dipole moment, and therefore that type of the compounds are known as IR inactive. So these are the essential and the necessary condition for IR active and the IR inactive. So here, if you observe these two structures carefully, here the prominent peak observed in above carboxylic acid due to the carbonyl group 1710 per centimeter, and one is due to hydroxy group 2.0023600 per centimeter, 2500 to 3600 per centimeter. This clearly indicate that this peak is observed due to the hydroxyl group which is present in the acid, and these protons are responsible for acidity that I already explained in my previous lecture. Why these protons are highly acidic in nature, it can easily get dissociate, it produces as a H plus, and therefore we can say that protons are, and this peak very strong and the broad peak observed due to the OH stretching frequency. Why broad and strong peak? The broad peak is observed due to the hydrogen bonding, and as we know that there are the two type of the hydrogen bonding. One is the intermolecular hydrogen bonding and another one is the intramolecular hydrogen bonding. If such type of the hydrogen bondings are present, they produce generally as a broad spectrum is observed in a IR spectra or IR spectrum. Now here the peak due to the carbonyl group is observed around 1314 per centimeter, and another prominent peak observed around 1100 per centimeter. These two peaks in above case also as a two peak, and in the second structure also produce as a two prominent peak. One is due to the carbonyl group, one is another due to the CO stretching. But here remember the peak around 2500 to 3600 per centimeter, 2500 to 3600 per centimeter, this peak is absent in the ester. So in this way we can easily distinguish ester from the acid, because the carbonyl group is here approximately that by observing that peak, its shape and size, the organic chemist easily recognize that peak is due to the carbonyl group. In addition to the next distinct peak, one due to the OH, that clearly indication of the OH stretching frequency, and the peak around 1100 per centimeter, that clearly suggests that there is a ester group is present. So in this way we can easily distinguish these two compounds from each other by this. Now let's move on to the next point that we are going to discuss, amines and the amides. Next one, let us see here the what type of the, suppose as a benzoic acid. Let me show the one. Here I am displaying the spectra for benzoic acid, which is a mono substituted aromatic compound once again, that we know that. benzoic acid, the normally if conjugation is present, generally carbonyl group or whatever IR absorption peaks are decreases. The reason behind I am going to explain while studying the factor affecting the IR frequencies, and that time we are going to discuss that one. But here generally, so here how many peak, prominent peak will be observed in this particular organic compound, which is the name of this compound is the benzoic acid. If you see here, there is a carbon-carbon double bond, that is aromatic carbon-carbon double bond. The appearance of peak around is generally 1500 to 1600 per centimeter, clearly indicate that the presence of aromatic compound is there. Let's see another one. One carbonyl group is present and that carbonyl peak is appear around. Here is a 705 per centimeter, we can call it here. So around the 1700, either the value is raised or lower, that depending upon the number of factor affecting the IR frequency, such as conjugation, hydrogen bonding, electron donating group, electron withdrawing group. So these are the factor which either increases or decreases. That type of the factor in detail we are going to discuss in our next lecture. But here just remember, here are the prominent peak. Now here OH stretching frequency, here OH stretching frequency again appear around 2500 to 3600 per centimeter, very broad peak. If you see over here, here you are going to get this type of the broad peak is observed over here, and one is due to this carbonyl group and another one that is carbonyl after that 1600, and here maybe as this peak, and another maybe such type of the peaks are in a aromatic region. So this is a spectra. If you observe these spectra carefully, this peak is due to the OH stretching frequency, broad and the strong peak, and if you see this is a recognizable peak observed due to the carbonyl group C double bond O, and look at one another peak, this is due to the carbon-carbon double bond, and if you see there are number of another peaks are the signal or the band, and these bands are due to CH bending vibration or the monosubstituted pattern that are showing, and this because this is fallen in the aromatic region and this is are the functional group region. These two are the very important region in as far as organic chemistry IR spectroscopy is concerned. So in this way we have learned this one. Now next point which we are going to discuss over here, that is amines and amides. Next point is amides and the amides. As we know that once again amides and the amide. Let's see what are those structures. Here generally A, B, C, E, F may be as amines, and next one is amides, right? Amides and the amines. Amines, we know that the general formula of amines is R NH2, and whereas amides are RC double bond O NH2. The general statement regarding these organic chemistry, those organic compound containing nitrogen atom are found to be basic in nature. If you see these two structures carefully, whatever the general statement about that organic compound which is true for amines, they are basic in nature, no doubt about it. But if you follow the same rule for amides, so amides are not obeying that above rule, not following the above rule as per the guideline for basicity. Even though amides are containing NH2 group is found to be neutral in nature. Why? The reason behind it, the lone pair which is available on nitrogen atom is involved in a delocalization. It is not free for donation, and therefore amides are found to be neutral in nature. So that is it. But here, as far as the IR spectroscopy is concerned, the amines are further classified into primary amines, secondary amines and tertiary amines. And let us see, suppose as a with the example here, CH3 NH NH, then CH3 another, this is a secondary amine which I am showing over here, CH3H, and now tertiary amine CH3 N, here CH3 and CH3. That is the tertiary amine, last one. This will be the primary amine, secondary amine, tertiary amines. And now if you observe the IR spectrum of primary amine, you would observe there are two peaks in IR spectrum due to the NH tracing frequency 3300 and one around 3400 per centimeter. So two peak is observed due to the NH tracing frequency. This is a prominent peak and the most informative peak observed in amines. In the second, the peak appear around 3300 per centimeter. It clearly indicates that this is a NH tracing and which is observed in a secondary amine, and from this, and if you take as a spectra, no peak is observed around 330 in 3000 and above 3000 to 3600 per centimeter, and that clearly indicates that there is a tertiary amine is present. By IR spectroscopy, we can easily distinguish primary amine, secondary amine and the tertiary amine from each other just by observing the bands of IR spectrum or the signal or the peak from IR spectrum. Okay, so that is there. And the aromatic now here is amides. Generally, how do you suppose as a CH3, C double bond O and the NH2. Here, look at here, the amide containing as a this one primary amide. So it will give, these are the peak due to the NH, this type of the peak. In addition to that, this carbonyl group, the peak is appear around 16-19 per centimeter. See the carbonyl frequency generally appear around 1710 to 1715 per centimeter, which is a characteristic of carbonyl compound, but it is a slightly lower. And why this one is a lower one? Due to the resonance effect that is in the conjugation, and due to that reason the carbonyl frequency goes on decreasing. So I think these are the some of the functional group which we have discussed over here. So the next point that we are going to discuss that is aromatic compound and their substitution pattern. As we know that if aromatic compounds are present, the appearance peak around 1500 to 1600 per centimeter clearly suggests that there is a aromatic compound is present. And we know that aromatic compounds are present in there are different substitution patterns are there, monosubstituted, disubstituted and trisubstituted or polysubstituted, generally ortho, meta and the parasubstituted, and by observing that prominent peak we can easily find out its pattern. So I think with this let us stop today here. Remaining in the next lecture we are going to discuss about factor affecting IR absorption frequency. With this let us stop today here. Thank you. Have a nice day.